In this video, we discuss the next topic, series. Now, first we define the definition of series. Let A is a sequence of real numbers. Then the expression A1 plus A2 plus A3 plus dot 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 plus AN and so on up to infinity is called infinite series. Notation: we denoted the infinite series by summation n equals to 1 to infinity an, or simply summation a. Sometimes we starting in from 2 or 3 or 4 and so on. That is summation n equals to 2 to infinity, or summation n equals to 3 to infinity, etc. Is also a infinite series. Next we discuss the convergent series. Convergent series. A series summation n equals to 1 to infinity converges and convergent to A if the sequence Sn is convergent and limiting value of Sn is A, where Sn is called the partial sum, that is A1 plus A2 plus A3 plus and so on up to A. This is called the partial sum, and n equals to 1, 2, 3 and so on up to A. So this is the definition of convergent series. Now we consider an example. So that 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 and so on up to infinity is convergent. Solution: here given series is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on. Now we write 1 by 2 minus 1, 2 into 3. Here 1 also can be written as 3 minus 2. Here 1 can be written as 4 minus 3. Basically we find a common type of expression or common type of pattern for solving these kinds of problem. If we divide 2 by 1 into 2 minus 1 divided by 1 into 2 plus 3 by 2 into 3 minus 2 by 2 into 3 plus 4 by 3 into 4 minus 3 by 3 into 4 and so on. So after dividing we get 1 minus 1 into 2 means 2 plus 1 by 2 minus 1 by 3, cancel 3 we get 1 by 2, cancel 2 get 1 by 3 plus cancel 4 get 1 by 3 minus cancel 3 get 1 by 4 and so on. So if we remove these brackets, then we have minus 1 by 2 plus 1 by 2 cancel out, minus 1 by 3 plus 1 by 3 cancel out and so on. So we get 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and so on. So here we assume A1 1 minus 1 by 2, A2 1 by 2 minus 1 by 3, A3 1 by 3 minus 1 by 4 and so on. So from this we guess AN. So when A1 then is starting from 1 by 1, since 1 can be written as 1 by 1, minus 1 divided by 1 plus 1, and when A2 then starting from 1 by 2 minus 1 divided by 2 plus 1. So when AN is starting from N, first quantity is 1 by N minus 1 divided by, next number is just add one more, 1 plus 1 2, 2 plus 1 3, 3 plus 1 2. So the next quantity is n plus 1. This is the nth quantity. So the partial sum Sn equals to 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and so on, and the last one is 1 by n minus 1 divided by n plus 1. So cancelling minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and cancelling the next term plus 1 by 4 and so on. So the remaining part is 1 and the last quantity minus 1 divided by n plus 1. So Sn equals to 1 divided by 1 minus 1 by n plus 1. So if we solve this, then we have n divided by n plus 1. Now limiting value of Sn is limit n tending to infinity n by n plus 1. For easiness, we write this expression in this format. So keep this format 1 minus 1 by n plus 1. While we taking n tending to infinity, then n plus 1, which is also goes to infinity as n tending to infinity. So 1 by infinity is goes to 0. So when we are taking infinity, this part becomes 1 minus 0. So this is 1, and 1 is a finite quantity which is a finite quantity. So by the definition of convergent series, we can say that the given series is convergent since its partial sum, the integral of the partial sum is finite. So the given series is convergent. Next we define the divergent series. Divergent series, the series summation n is divergent if summation n is either plus infinity or minus infinity. Next we define oscillatory series. If Sn is oscillatory series, then if Sn is oscillatory series, no, only Sn is oscillatory sequence, then the series is called oscillatory series. Sn is a sequence. Sn is a sequence. Example: summation n equals to 1 to infinity minus 1 to the power n minus 1 is an oscillatory series since summation n equals to 1 to infinity minus 1 to the power n minus 1, putting 1 first, 1 minus 1 minus 1 to the power 2 minus 1 plus minus 1 to the power 2 minus 1 minus 1 to the power 4 minus 1 and so on. This value minus 1 to the power 0 is 1. This value minus 1 to the power 1 minus 1 next plus 1 next minus 1 next, plus 1, and so on. Now we see that when n is even, so as for example, if taking n equals to 4, then we terminating here, and the result is plus 1 minus 1 plus 1 minus 1. So this minus 1 plus 1 cancelling, and this minus 1, this plus 1 cancelling. So this becomes 0. And if n equals to or, as for example, if we taking n equals to 3, then we terminate here up to this part, minus 1 to the power 1 minus 1, minus 1 to the power 2 minus 1, and minus 1 to the power 3 minus 1. So terminating here. So this minus 1, sorry, this plus 1 and this minus 1 is cancelling, and remaining number is 1. So this is the result. So when n equals to even, we get the summation value is 0, and n equals to odd, we get summation value 1. So this oscillates between 0 and 1. So this is an oscillatory series. Next we discuss some important tests. First we discuss the p-test. P-test statement. This is of positive terms. Summation 1 by n to the power p, n starts from 1 to infinity, where n is the natural number. This is the positive term series. Now summation n equals to 1 to infinity 1 by n to the power p is convergent if the value of p is greater than 1, and summation n equals to 1 to infinity 1 by n to the power p is divergent if p is less or equals to 1. Some example: summation n equals to 1 to infinity n is divergent since here 1 by n to the power 1, n to the power 1 means it is simply 1 by n. Now if we write n to the power 1, then compare the original form with this, and we get here in this case p value is 1, and which is also lesser than or equals to 1. So by the statement we say that the original series 1 by n is divergent. Next we will consider the series summation 1 by n square n equals to 1 to infinity. It is convergent. Why it is convergent? Since here if you compare original form in 1 by n square, so 1 by n to the power p, so p value there is 2, and which is greater than 1. So by the statement of the p-test we say that the series 1 by n square is convergent. This is number 2. again if you consider summation n equals to 1 to infinity 1 by n to the power square root of n, which is also divergent. Since here t value is half, which is less than or equals to 1, since square root of n also can be written as n to the power half, and if you consider the standard form, then you have p value is up, and since p value is up, and by the statement which is lesser or equals to 1, so this is divergent. And the next example, consider summation n equals to 1 by infinity, summation n equals to 1 to infinity 1 divided by 3 to the power 1 by n to the power 3 by 2, which also is convergent. Since 3 by 2, here t value is 3 by 2, which is 1.5, which is greater than 1. So by the p-test we say that 1 divided by n to the power 3 by 2 is convergent. Next we discuss very important test, comparison test. First we assume that L equals to limit n tending to infinity n by n. This is L. Now the value of L, when change its value, then for some values of L, when n equals to 0 or infinity or some finite non-zero, then we conclude some result about the convergence and divergence of the series summation A. So we write one by one here. So we consider the following cases. Now number one case is 1 when L is 0, that is limiting value of n by bn is 0. Then the result is summation bn is convergent. This implies that summation a is also convergent. This is the number one. And number two, summation an is divergent. This implies that summation bn is also divergent. This is the first result. When n equals to 0, summation bn convergent means summation n is convergent. And number two, summation n is divergent implies that summation bn is also divergent. This is the case number 1, and next we write the case number 2. Case number 2, when L is infinity. So in this case, when an is convergent, when an is convergent, this implies that summation Bn is also convergent. And summation Bn is divergent this shows that summation n is also divergent. So this is the true result. When summation n is convergent, this implies that summation n is convergent, and when summation n is divergent, then summation n is also divergent. So this is the case number 3 when n is infinity, that is the limiting value of n and bn, n by bn is divergent. Now we discuss the last case when n becomes any finite number, any finite non-zero quantity. N is finite with non-zero quantity, because when n equals to 0, this case which we already discussed in the previous case. Then when L is finite, then summation Bn is convergent if and only if and only if summation n is convergent, and if summation Bn is divergent if and only if and only if this IWF is written as if and only if summation n is also divergent. This is the condition when n is infinity. Summation n is convergent if and only summation n is convergent, and summation n is divergent if and only summation bn is divergent. Now if and only means a, if and only if b, its meaning is a implies b and also b implies a. If a hold, then b also hold, and if b hold, then a also hold. This is compactly written as a if and only if b. So this is the 3 case of the comparison test. Now we discuss some problem about comparison test. Next we discuss the problem test the convergence of the series 6 divided by 1 into 3 into 5 plus 8 divided by 3 into 5 into 7 plus 10 divided by 5 into 7 into 9 and so on. So you first recognize the general nth term. First A is find general nth term. This is our first thing. Here this is the first term of the series, this is the second term, this is the third term, and so on. Here we easily see that when we are in the first term, then the number in the denominator part starting from 1, and when we are in the second term, in the denominator part the number starting from 3, and when we are in the third term, then in the denominator part the number starting from 5. Now if we observe these three patterns, 1 goes to 1, 2 goes to 3 and 3 goes to 5. From these three patterns, if we write 1 in the format 2 into 1 minus 1, then 2 into 1 is 2, 2 minus 1 is 1, and 3 also can be written as 2 into 2 minus 1, and 5 also can be written 2 into 3 minus 1. Here we see that the number 2 is common. 2 into 1 means for the first term here we write 1, for the second term here we write 2, and for the third term we write 3, and in the 3 case we subtract 1, 1 and 1. So when we in the nth term, then from this format we can easily recognize the nth term. The starting number of the denominator part is 2 into n minus 1, which is related n is related with the nth term. Since 3 is related with the third term, 2 is related with the second term, and 1 is related with the first term, and minus 1 minus 1 minus 1. So in similarity we write minus 1. So it is clear that first number in the denominator part in the nth term is 2n minus 1. Next is very easy. Here we see that 3 minus 1 is 2, 3 minus 5 is 2, 7 minus 5 is 2. So the next number in the denominator part is just 2 more of the previous one, that is 1 plus 2, 3, 3 plus 2, 5, and 5 plus 2 is 7. So the next number in the denominator part is 2n minus 1 plus 2, and also in the last number 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So we add more 2n minus 1 plus 2 plus 2. This is the nth term in the denominator part, and the numerator part is very simple. Here 6 we write 5 plus 1, so the last number in the denominator part, and add more 1, and 8 is 7 plus 1, 10 is 9 plus 1. So in the nth term the numerator part is 1 more from the last number in the denominator part, that is the last number of the denominator part in the nth term is 2n minus 1 plus 2 plus 2, and add more. So this is the general nth term. So this series can be written as 2n minus 1 plus 2, which is 2n plus 1, and the last part is 2n minus 1 plus 2 plus 1 plus 1 plus 2 plus 3, and this part is 2n minus 1 plus 2 plus 2 plus 1, which is 4 plus 2. This is the general term starting from n equals to 1 to 2. So the given series can be written in this format: summation n equals to 1 to infinity 2n plus 1 divided by 2n minus 1 into 2n plus 1 into 2n plus 3. So we assume an equals to 2n plus 4 divided by 2n minus 1, 2n plus 1 and 2n plus 3. So the given series also can be written as summation n now we choose Bn, taking Bn as 1 divided by, here you see that in the numerator part of n the highest power of n is 1 and in the denominator part highest power of n is n into n which is 3. Take this difference, 3 minus 1 equals to 2. So taking Bn as n to the power highest power in the denominator part of n which is 3 and the highest power of the denominator highest power of n in the numerator power which is 1, taking difference. So taking Bn as n square and consider the series summation n equals to 1 to infinity 1 by n square. Now taking the limiting value of an by bn which is n means 2n plus 4 n means 2n plus 4 divided by 2n minus 1 2n plus 1 into 2n plus 3 divided by bn. Bn means 1 by n square. N is 1 by n square. So calculate this. Limit n tending to infinity 2n plus 4 into n square divided by 2n minus 1 2n plus 1 and 2n plus 3. Now take common n from the first part. We have n into 2 plus 4 by n into n square and taking common n from here, here and here. So n into 2 minus 1 by n into n 2 plus 1 by n into n into 2 plus 3 by n. Limit n tending to infinity n square into n into 2 plus 4 by n into n which is n cube and the remaining part is 2 minus 1 by n 2 plus 1 by n and 2 plus 3 by n. Now cancel both n cube and taking limit n tending to infinity. Now since n tending to infinity, so 1 by n goes to 0. So this part becomes 0, this part is 0, this part 0 and also this part is going 0 when n tending to infinity. So the remaining part is 2 divided by 2 into 2 into 2 which is 1 by 2 which is non-zero finite number and limit n tending to infinity n by bn is L. So L becomes 1 by 4, which is non-zero finite quantity. So n and n is convergent or divergent even only if summation dn is convergent or divergent. Now we see that summation dn n equals to 1 to infinity is 1 by n square, which is convergent by p-test where p equals to 2, which is greater than 1. So by the statement of the p-test we say that when p value is greater than 1, then the series is convergent. So dn is convergent, and since L is non-zero finite number, so by the comparison test we say that summation k is also convergent by comparison test. So the original series 6 divided by 1 into 3 into 5 plus 8 divided by 3 into 5 into 7 plus 10 divided by 5 into 7 into 9 and so on is convergent. So this is the complete problem solution, and now we stop here, and if you have any doubt, so please join the Telegram group